The content of citric acid in citrus juice. In this experiment, we wanted to determine the concentration of citric acid in citrus juice. We could determine this by doing a titration with citric acid and a titration with lime juice, and then comparing our results, and at the end finally calculating the concentration of the acid in the juice. We began with the titration of the citric acid. Here we started out by doing colorimetric titration, where we used 2 to 3 drops of phenolphthalein as an indicator. We used 25 milliliters of citric acid that we transferred to a conical flask and then titrated the acid with 0.1 molar sodium hydroxide from a burette. During the titration, we used a magnet and a magnetic stirrer to constantly mix the solution. The solution started out as colorless but turned pink with 1 drop of sodium hydroxide when we reached the endpoint because of the phenolphthalein. Here we reached the endpoint after adding 19.7 milliliters of sodium hydroxide. We then repeated the titration of citric acid, but this time we used a pH meter instead of an indicator. We once again used 25 milliliters of citric acid that we transferred to a conical flask, and then titrated the acid with 0.1 molar sodium hydroxide from a burette. Here we also used a magnet and a magnetic stirrer to constantly mix the solution. During the titration, we measured the pH by using a pH meter and graphical analysis. We added 0.5 milliliters of sodium hydroxide at a time until we were near the endpoint, and then we started measuring the pH after every 0.25 milliliters of sodium hydroxide was added. We stopped the titration when all 30 milliliters of sodium hydroxide had been used. Afterwards, we repeated these two forms of titration with 25 milliliters of diluted lime juice. During the colorimetric titration, we reached the endpoint when approximately 17.7 milliliters of sodium hydroxide had been added. We could then take the data we had gathered from the pH titration of citric acid and the pH titration of the lime juice and plot two graphs where we had the volume of sodium hydroxide in milliliters on the x-axis and the pH level on the y-axis. Here we could also conclude that both titration methods worked, since the endpoint of the colorimetric titration of the citric acid at 19.7 milliliters was very similar to the endpoint of the pH titration of the citric acid at 20 milliliters. And the endpoint of the colorimetric titration of the lime juice at 17.7 milliliters was very similar to the endpoint of the pH titration of the lime juice at 17 milliliters. We are able to understand why the titration curves of the two pH titrations look like this by looking at the reaction schemes for the titration of citric acid. Here we can see that every time sodium hydroxide is added, the acid loses a hydrogen atom. This makes sense since the definition of an acid is that it wants to donate hydrogen ions. If we look at the first and second reaction, we can see that the acid goes from being a medium strong acid to a weak acid, and then it goes from being a weak acid to an even weaker acid. Even though the pH changes when these reactions happen, the pH does not change drastically enough for it to be seen on the titration curve. However, in the third reaction, it goes from being a weak acid to a weak base, and this change in pH is big enough to be seen on the titration curve. But even though we are not able to see the first two endpoints of the titration curve, it does not mean that they aren't there. We can roughly find the other two endpoints by taking 1/3 of the sodium hydroxide used to reach the third endpoint and 2/3 of the sodium hydroxide used to reach the third endpoint. Then the other endpoints will approximately be around 6.67 milliliters and 13.33 milliliters. We can now use the third endpoint to calculate the concentration of the citric acid in the solution used for the titration. When calculating this, we have to be aware that the sodium hydroxide and the citric acid reacts 3 to 1. First, we have to find the amount of substance of the sodium hydroxide, and then, because we know the equivalent amount is 3 to 1, we can divide the result with 3 and get the amount of substance of the citric acid. Now we are able to insert our numbers into the formula and calculate the concentration of the citric acid. To see how accurate our results were, we wanted to compare the real pKa values of the citric acid to the ones that we had found. The real pKa values for the citric acid were 3.13 for the first endpoint, 4.76 for the second endpoint, and 6.4 for the third endpoint. To find the pKa values that we had measured, we wanted to look at the titration curve. Here we could take half of the amount of sodium hydroxide added to reach every endpoint and look at the pH value for these points. The pH values here should be equal to the pKa values of different endpoints. Our pKa values ended up being approximately 3.42 for the first endpoint, 4.04 for the second endpoint, and 4.76 for the third endpoint. Once again, to see how accurate our results were, we also wanted to calculate the pH levels for the first and second endpoint and compare them to the pH levels that we could see on our graph. To calculate the pH for the first endpoint, we could use the formula pH equals the negative logarithm of the concentration of hydroxonium ions, since the pKa value for this endpoint is below 4. To find the concentration of hydroxonium ions in the solution, we could use the formula where the concentration of hydroxonium ions to the power of 2 divided by the concentration of the acid minus the concentration of hydroxonium ions equals the acid constant, which is the same as x to the power of 2 divided by the concentration of the citric acid minus x equals the acid constant. And we had already looked up this acid constant, so we now only had to find the concentration of the acid. Because this is the concentration at the first endpoint, we had to add the volume of the added sodium hydroxide to the volume of the citric acid. And then we could insert our values to the formula for the concentration. We then solved the equation in Maple and got two results. We were however only interested in the positive result, since the concentration of hydroxonium ions can't be a negative number. And now we could insert our concentration into a formula for pH, getting a pH of 2.44. On our graph, we could read that the pH of the first endpoint should be around 4.05, which gives our result a percentage deviation of 93.75%. We then repeated this process for the second endpoint, but here we had to use another formula for the pH, since the pKa value for this endpoint was above 4. Here we once again added the already added amount of sodium hydroxide at this endpoint to the volume of the citric acid at the beginning, and then inserted the numbers into the pH formula and got a result of 3.26. Compared to the pH of approximately 4.45 that we could see on our graph for this endpoint, we had a percentage deviation of 40.18%. By looking at the two titration curves, we can see that they are very similar, and this must indicate that lime juice contains citric acid. To calculate the concentration of the citric acid in lime juice, we want to look at the graph for the titration of lime juice. Here we can see that the volume of sodium hydroxide added to reach the endpoint was 17 milliliters. Because we also know that the concentration of the sodium hydroxide is 0.1 molar, we can now calculate the amount of substance of the sodium hydroxide and therefore also the amount of substance of the citric acid in lime juice, since the equivalent amounts are still 3:1. And now with these numbers we can calculate the concentration of the citric acid. However, because the 20 milliliters of lime juice was diluted with 250 milliliters of water, it means that we have to take that into account as well. Therefore, we first have to find the amount of substance for the citric acid in the diluted solution by multiplying the concentration that we have just found by the volume of the added water. And now we can find the concentration of the citric acid in the lime juice that we have used, which ended up being 0.29 molar.